Okay, so geography has an environmental perspective, but we also have a science perspective. So I wanted to take a moment to reflect on what is science. It's been thrown around a lot more these days, it seems like. People like Bill Nye and Neil deGrasse Tyson kind of really bringing the idea of science into more mainstream culture. Like you hear phrases like, I'm going to science the heck out of this, or let's go do science, and just kind of using this very general term loosely. And I think it's important to take a second to reflect on it. We're all taking this course as your science elective. Very few of you are actually geography majors taking it for your major as part of your major, but you have to take it as your science elective. So it's important that we take a moment, especially if you only take 2 science classes while you're at JSU, to stop and think about and appreciate the perspective that science takes. So what would be your personal definition of science? Maybe take a second to think about it before we dive in and you just passively listen again. Maybe actively engage your brain and think about, reflect on what is science. When I ask my phone, when I say, Siri, what is science? This is what comes up. Science is the second album of American rock band Incubus, released in September 9th, 1997 by Epic Records. Not quite what we have in mind, although back in the 90s I was a fan of Incubus. Not quite what we have in mind. So what is your personal definition of science? What is science? What does it involve? And let's go beyond just thinking about, I'm not even going to give you a definition of it. We're going to talk around it and give some ideas. This is one of my favorite people out there, Neil deGrasse Tyson. I like listening to his astrophysics blogs and his podcasts and anything he puts on YouTube, and his updated version of Cosmos, all kinds of cool stuff out there. And I came across this at some point in one of my many different things I read and watch that he does. He says means that you have to do whatever it takes to avoid fooling yourself into thinking something is true that is not, or that something is not true that is. So take a second and digest that. Yeah, the idea of science emerges out of wanting to find answers, out of satisfying our curiosity. Many humans are curious. In fact, a human that's not curious probably has some type of emotional or some type of issue affecting their psyche and their day-to-day patterns that's preventing them from their natural curiosity. Or maybe you just were in school too long and teachers have beat out your curiosity, beaten it out of you. But I encourage you to be a curious person, to think and to not be satisfied with just the first answer you get, but to be skeptical minded. It's another thing scientists are, skeptical, not just taking someone's word for it, not allowing yourself to be fooled into thinking something's true that isn't true. In the world of fake news and with clickbait all over the internet, it's very easy to be tricked into thinking something's true or something's not true, when in fact maybe it is. So science takes that perspective when it's asking questions. It doesn't want to be fooled. It wants the truth. Also, wrestling is a big part of my background, and Neil deGrasse Tyson is, as well, which I think that's pretty cool. Science. Oh, here we go. Making new friends. Not exactly what we meant. So here's a classic, Young Frankenstein. And I found myself going back to Mary Shelley's Frankenstein and reading it over the summer, and I came across this really cool passage, which I'm not going to read it to you on this video, but go ahead and pause it and take a second. It's a pretty neat description of science taken from Frankenstein. Is geography a science? Well, yes. A lot of what we do, especially in physical geography, does involve scientific thinking. And of course, usually when you ask someone to define science, what quickly comes up is following the scientific method. And we do that in a lot of our studies in geography, when we're studying the world, using tools, taking measurements, using statistics. One thing we want to highlight now is not this, we don't want to just come away with an elementary idea of science as being this very strict step-by-step scientific method. In the real world of science, it's much more complicated, convoluted. It's much more like a web than this chain of step, 1, 2, 3, 4, and so forth. And it involves a variety of things. So I kind of want to start before we get to the scientific method thinking about a scientific checklist. Are you focusing on the natural world? Well, in geography, we certainly do. As do other scientific disciplines like chemistry and physics and biology. Do you aim to explain the natural world? That's the whole idea, trying to answer your questions. Here, though, is where it becomes more sciencey. Can you use testable ideas, falsifiable types of tests, tests that can be set up to pass or fail? You rely on evidence, and evidence comes in a variety of forms. Do you involve the scientific community? One thing that I love about true science is that it should be communal, sharing of the information, not hoarding it to yourself to profit from. Sometimes that does happen in science, especially when you talk about trying to patent ideas and engineer new gizmos. There's a place for that, but what we're talking about here in physical geography involves a scientific community, sharing ideas, sharing studies, referencing somebody's studies. In fact, there's no way you can get a scientific paper published if you don't have a list going beyond 15, 20, up to 50, 100 different scientists and their work referenced in your article. If you just turn in your own paper with no reference to the scientific community, it's not going to have any validity because we always build off of other people's work. Leads to ongoing research. Yep. And benefits from scientific behavior. Okay, so geography does all these things on our checklist. Here again is us doing our water quality testing the waters. In this particular image, we're looking for specific types of bacteria, and when we see this blue and purpley color, that is not necessarily a good thing for our local streams to have. That's strands of E. coli. And not all E. coli are deadly and harmful to us, but a lot of them are. So we don't like to see very high counts. When we think about the scientific method, it involves a variety of steps. So the first thing is something catches your attention. You make some type of observation that you can't explain. You need to construct a hypothesis. And hypothesis is the key word here. We don't like to use theory for number 2 because we reserve theory for things that cannot be disproven. Hypothesis, though, is the word we use for our best educated guess. And that hypothesis needs to be testable. If you have a guess that you can't test, then you're not doing science. Right, so if something catches your attention at night in your bedroom and you think it might be a ghost, your hypothesis is that there's a ghost in my closet making those noises. Can you test that? You can set up video cameras and try to record it or put out other types of instrumentation and try to figure out what's going on. Maybe look at your windows and see if there's wind coming in your windows. You can do a test to see if your hypothesis, your educated guess, is true or false. When you design your test, you want to be able to predict your outcomes. So if you are making a test that something very simple as there's a ghost in my closet, and my test is I'm going to put out a video camera, and I predict that this video camera will record a transparent human-like figure floating in my closet, pushing on my hangers and on the door, making noises. You can test that, and if your video comes back showing your prediction, then it's more likely that your hypothesis was correct. And if not, then you go back to the drawing board and either construct a different test or design a different hypothesis. You can conduct your experiment, and you can draw conclusions. And one thing that we often, even scientists will throw this around sometimes incorrectly, science doesn't prove things. Mathematics can prove things. In science, we don't prove things. We disprove alternate hypotheses. And when we get to a certain point where we cannot fathom any other explanation with our rationale, at that point we deem it a theory. But we don't say we've proved anything. We just have disproved a bunch of other things. And that is how a true scientist thinks.